In this lesson, you will be learning the physical states or phases of matter. So they are S for solid, L for liquid, AQ for aqueous, and G for gas. If you're giving a chemical reaction or chemical equation that looks like this, magnesium is a metal. If you look at the periodic table, okay, it's on over here. It's on the left side of the staircase. It's a metal. It will be a solid, so there's an S. Hydrochloric acid is aqueous. MgCl2, magnesium chloride, is also aqueous, and H2 is a gas. If you don't know, I'd have to tell you what those are. I just want to make sure that you have a visual of what the solid means, okay? So if you look at the phases of matter, pretty easy. Solid, liquid, gas. Solid has a definite position and composition. So those individual atoms are not changing positions, but they are vibrating in place. In liquid, they are just changing positions, but there's still some interactions between them. In gas, they can move about randomly, and there is no attraction between this gas molecule and this gas molecule whatsoever. Okay, so when you're looking at a solid, you have three different types of solid. You can have an ionic solid, which is made of ions. So an ion is when you have MgCl. You have Mg is a +2 charge, Cl is a -1 charge. You have a metal and a non-metal, and you have an ionic bond. An ionic solid looks like this, where you have this sphere is the Cl- and the Na is the +1. Okay, so that's what an ionic solid looks like. In a metallic solid, it looks a little bit different, where you have, in this case, it's just, let's say it's just magnesium solid. Magnesium is a metal. So you have the +2. In a solid, you would have the magnesium bonded to another magnesium, +2. And what's holding them together are the valence electrons that's free to move everywhere, as depicted by this picture right here. So that's a metallic solid. The metals are on the left side of the staircase. You can also have a molecular solid. So a molecular solid is when you have a nonmetal plus a nonmetal substance. For example, this is iodine. You can see that down there. The solid is I bonded to another I covalently. So that is one I2 molecule. So that's I2. So this I2 has interactions with this other I2. And in a solid, they're together. So this is what it looks like. Okay, so you can have I2 as a solid. You can also have water as a solid. That's called ice. So this is H, and O, and here's another water molecule right here. In a solid, there's an interaction that holds them together, but can be easily broken as you boil it. So you have to melt it first. That makes them move positions, and then when you boil it, it totally breaks that bond between the water molecules. Okay, so you have an ionic solid made of ions, metal plus nonmetal, and it looks like this. Okay, you have a metallic solid made of metals, and the electrons are what's holding them together, that freely moves. Here, the electron is not moving. It's stuck on the Cl-1. Over here, you also have a molecular solid where you're made of nonmetal. Okay? So the liquid is easy. From a solid, you melt it, you give it a little bit of energy, and instead of just vibrating in place, they can now freely move past each other, but still in contact. When you have something that's aqueous means when you take salt and you put it in water, the Na and the Cl, these two circles right here, are separated by water. Okay, so here's one ion, and here's another ion. Okay, so if you watch this video here, it shows you how an ionic solid is dissolved. So you would have the Cl-, And water is polar. It has, oh wait, so the H should be pointing towards the Cl because the H is partially positive and the O is partially negative because it is more electronegative. So when you're drawing this, you have to make sure that the H is always pointing towards the negative ion. So the Na plus, since O is partially negative, so the O should always be pointing towards the positive ion. So this is what it looks like when something is aqueous. That means dissolved in water. Okay, so a gas, no fixed shape, no interaction between the particles. So you might wonder, this is nitrogen gas. Why is nitrogen gas N2? Why isn't it just N by itself? Okay, so the reason lies because N cannot exist alone floating around. And the reason is based on its valence electrons. Look at the periodic table. So the periodic table is here. Nitrogen has 5 valence electrons, 1, 2, 3, 4, 5. Oxygen has 6, fluorine has 7. So I'm going to talk about N, O, and F, okay? So let me show you why N cannot exist by itself. It has to exist as a diatomic molecule. So N, nitrogen has 5 valence electrons, okay? So, and we're going to use another N, okay? So since N has put the valence electrons in a bucket, there's five of each one, so a total of 10, okay? So 1, 2, bonding pairs first, 4, 6, 8, 10, okay? 2, 4, 6, 8, 10. If you just have N by itself, it would be 1, 2, 3, 4, 5. So N cannot float around by itself. This will never ever happen, okay? Because it doesn't have 8, so it's not stable. So with the diatomic, this is what happens. Since this only has 6, you're gonna move these in. Just change the color. And you're also gonna move one of these in, it doesn't matter which one. So now it has 2, 4, 6, 8, 2, 4, 6, 8. So this N actually has a triple bond. So N always exists as a diatomic. Diatomic, meaning composed of 2 atoms. Okay? There are other diatomic molecules that you must remember. It is N, O2, and F2. Okay? Now let's go ahead and do the Lewis structure for oxygen. O2. You have O and an O, bucket. Oxygen has 6 valence each, total of 12. So I'm going to do bonding pairs first. 2, 4, 6, 8, 10, 12. Okay, so you move them in because there's not enough. Move these in. And there, 2, 4, 6, 8, 2, 4, 6, 8. So oxygen has to exist as O double bond O, as an O2. Cannot exist as O because O with 6 valence electrons is just not enough. Okay? Next, let's talk about hydrogen, or no, fluorine. Fluorine has 7. 1, 2, 3, 4, 5, 6, 7. Cannot exist by itself, so it's going to have to bond with another fluorine. So everybody has 8, so fluorine is also diatomic. And that goes along with all the ones with 7 valence electrons. And that includes F2, Cl2, Br2, I2, At2. Okay, so those are all diatomic. You have to memorize the diatomic molecules, and it goes like this: NOF, N2O2, F2, all of these, and then H. H is also diatomic because H only has 1 valence, so it's going to take another H. Now they have 2 each. Okay, they're sharing those 2, and 2 is enough in the first energy level with 1s2. So, and H2. So all of those are diatomic. The way I remember it is it spells H2, 2, N2, Cl2, Br2. These are all the diatomics that you must remember. Br2, I2, and F2. That spells Honkel Brief, and that's a mnemonic device for you to remember it. Honkel Brief. Okay, and that's it.